So when you revise kinematics for class 11 syllabus, you have to know motion in one dimension and motion in plane, that is two-dimensional motion. So motion in one dimension in the new CBSE book, new NCERT book better to say, motion in 1D in chapter 2 and motion in a plane including vector in chapter 3. So in this session I will be discussing kinematics for class 11, means it includes motion in 1D and motion in 2D. Vector also obviously is a topic over there, but vector I will discuss in different session. In motion in 1D, how are you going to revise, that is very important. Motion in 1D consists of those concepts of average displacement, average velocity, average acceleration, instantaneous velocity, instantaneous acceleration. Actually there is no term like average displacement, total displacement. And average velocity is total displacement by total time. All these basic concept you have done before, just quick revise with me. So average velocity is given by delta S or delta X by delta T. This I am talking about motion in 1D. Okay, average velocity is delta S by delta T. Average, and then instantaneous velocity is what? Instantaneous velocity V equal to limit, I just remind you this concept also, delta S by delta T. This is nothing but ds by dt. Similarly, we can define average acceleration. Average acceleration is del V by delta T, and instantaneous acceleration A equal to dv by dt. This is also A equal to limit delta t tending to 0, delta v by delta t, and this is nothing but dv by dt. We have another expression for acceleration, A equal to dv by dt. This implies dv by ds into ds by dt. This is nothing but v dv by ds. And using all these, when you are going to revise, then you have to revise the derivation of equations of motion also by using calculus. But calculus, what will you learn for this chapter? This chapter for calculus you have to learn differentiation by first principle. Actually, first principle will give you the concept. First principle differentiation you need for your school based examination. In entrance examination, first principle has no application, but it is a concept building topic. When you write f dash a, derivative at x equal to a, which is limit a is tending to 0, f of a plus h minus fa by h. This h is actually change of a. This is first principle. You can expect simple questions based on it in school based examination, but how the rate of change of a quantity determined, that is understood by first principle. So when you are revising it, it is better you practice this kind of thing. By first principle, find the derivative of You all have done this. I just remind you, by first principle, find dy by dx when y equal to, say, something like x square, something like y equal to x minus 1 by x plus 1. This kind of problem you can practice, or say y equal to 1 by x plus 1. I hope all of you are ready with your pen and paper. You will be doing what exactly I am doing here. If some task is given, you should complete. So this is one of your work you have to complete at home. Okay? These three sums by first principle you will do once. Then differentiation by formula. Formula I need not revise here. Those formula you already know. But mostly we use this formula in motion chapter. Dgx of x to the power n is nx to the power n minus 1. This is n. This is not x. Okay. This is index. Index is n over there. And derivative of all those sin x, cos x, all these things you know. Sin x derivative is cos x derivative is minus sin x. But you mainly need derivative of this, derivative of constant equal to 0, and then derivative of this term. Sometimes in motion problem, this plays a vital role. I have explained this kind of differentiation in one of the video session earlier. This will be nx plus b to the power n minus 1 into a. Okay, this is very useful. Mostly these three formula is required. Sometimes log x, all these things required. You will be remembering that. So by formula, we need to differentiate by the use of this formula. Then, after the calculus and using this calculus concept, the derivation of equation also. What are the equations over there? Those are equations of motion. Equations of motion you must practice derivation once, that is v equal to u plus at. You must practice derivation by using calculus. A is equal to ut plus half at square. Number 3, v square equal to u square plus 2as, and distance travel in nth second or tth second, whatever, u plus half a into 2n minus 1. These are the equations of motion. You have to prove with the help of these expressions v equal to ds by dt, number 1, and acceleration equal to dv by dt or v dv by ds. You need to revise. And revision, when you are revising all these things, revision once more, then it is sure that you can apply those concepts when you are solving practical problems. I mean the problem in kinematics. Okay. So and when you are going to prove all these things, remember proof is required for school based examination only. Every time proof you will start with the initial condition and then derive it. When you are deriving, you must mention the initial condition and then start deriving. And they can ask you to prove it by graphical method also. This is proved by calculus, proved by calculus, and proved by graph also. I have to remind you some things from graph. Plotting of graph, all of you know, that is in case of v equal to u plus at, when you are plotting, the graph is going to be a straight line. If it accelerates, then graph will be like this. This is v equal to u plus at, graph will be like this. We don't take time negative, that's why. It is v equal to u plus at, and this part is the initial velocity u. A stands for uniform acceleration. This graph will change if retardation is there. Another thing I would like to remind you that A is equal to slope of this graph. Hope all of you remember what is slope of the graph. Slope of the graph is tangent of the angle made by it with positive direction of x-axis. You can take a line parallel to x-axis or time axis here also. Then this theta, tan theta is equal to dy by dx. That is geometrical meaning of derivative, and this is useful when velocity time graph or displacement time graph is parabolic. So v equal to u plus at, the graph is straight line when acceleration is there, but if there is retardation, the graph will take this form. This is time, this is v with some maximum velocity, its value reducing. This is the graph when acceleration is less than 0. This is velocity time graph. Okay. This is from some initial velocity u, gradually it is sloping down. And if you find the slope of tangent to the curve, this theta is obtuse. Theta obtuse means tan theta is less than 0. Okay. But what will happen for a curve? You have to remember this. Why? Because when you go for displacement time graph, then it is parabolic, no? Displacement time graph is parabolic. If accelerated motion there, if no acceleration is there, displacement time graph will be what? Let me remind you everything. For uniform velocity, displacement time graph is like this. This is a ST graph. Okay. This is case of uniform velocity. For uniform velocity, u remains constant. This time also slope of the graph, tan theta is equal to s by t or delta s by delta t, whatever you say. So when for uniform velocity, then it will be like this. If but velocity is variable, then what kind of graph is expected? If velocity is variable, then ST graph will not be a straight line. ST graph is going to be this kind of shape. Okay, this kind of shape you get when acceleration greater than 0. This is ST graph only. And when acceleration less than 0, the graph will be opening downward. This is the case of, and you know it is represented by the equation A is equal to ut plus half at square. Both the cases. For a greater than 0, this is the graph. For a less than 0, this is the graph. Okay. Now, if the displacement time graph or any graph is a curve, it is not a straight line, then problem arises. You have to remember that when it is a curve, then tangent drawn at a point will give you the direction, will give you the value of, slope of that tangent will actually given by the derivative at the point. So this is a graph. For any graph I am writing y equal to fx. If you draw tangent here, then slope of this tangent, tan theta equal to dy by dx. Okay. Slope of tangent at any point is given by tan theta equal to dy by dx. This you have to remember. If it is sloping down at any point, if you draw tangent here on the right side, it is sloping down. This time the angle made by it with positive x-axis is negative and tan theta will be dy by dx. At that point this is less than 0. Okay. So derivation of equation and graphical method, definitely I remind you when you are going to solve problem is this kind of things you need to revise. Then it comes motion under gravity. All the equations remain the same. I will not be surprised if I see that a question is asked in any school-based examination that prove this equation by calculus. V equal to U minus GT, projectile thrown upward, you prove this equation by calculus. They can ask you, procedure will be the same. You will be remembering, actually previously motion in one dimension we have considered it is motion in straight line, but that straight line may be horizontal, it may be vertical also. Basically there is no difference between horizontal and vertical motion. Only difference is for vertical motion, accelerated motion always will be there. Gravity plays important role. So these derivations may arise in motion under gravity also. Even this one, H equal to ut minus half gt square, and that v square equal to u square minus 2gh, and distance travel, height travel in tth second, ht equal to u plus, no, not plus, for upward motion it will be u minus half g into 2t minus 1. Similarly, we can draw all these for downward motion. For downward motion, what will be the case? For downward motion, if it is projected downward, then v equal to u plus gt, h equal to, proof may come by using calculus. So get ready for that. Here acceleration always positive, that is g. U square plus 2gh, and distance travel in tth second will be u plus half g into 2t minus 1. This time plus g. Now one thing I would like to remind you, which we have discussed previously, here I need to mention. It's a very important topic to be discussed here, that sign of the expression, sign of any physical quantity given here, you have to use properly. Like when the particle from the top of the tower thrown upward from here with velocity u, then how to write the equation of motion? After time t, the displacement of the particle, how to write? It is h equal to minus, this sign will be minus here, minus u into t plus half gt square, because g downward and u upward, that's why u is becoming minus, and g is along the direction of motion, that is plus. Similarly, if you write the equation for its velocity, it will be minus u plus gt. Please remember this. Only this thing will not change, I think. V square equal to u square. This is what? Minus u square is u square only, plus 2gh. This is not going to change. Okay. Now, a very important problem can be asked in MCQ question or in descriptive question. A particle thrown vertically upward with time t1, with velocity u, it strikes the ground after time t1. when it is thrown from the same height vertically downward with the velocity u, its time of flight, you all know, bt2, then it is simply dropped, that u equal to 0, time taken be t3. We have seen that, or you remember it, that t3 is geometric mean of t1 and t2. Okay, so if it takes time 8 seconds, this one takes 2 seconds. When it is simply dropped, it will touch the ground after 2 into 8, 16 seconds. So to find the distance traveled by the particle in 12 seconds, this is one of the example I am going to discuss. You can read, you can see the graph properly. Here, distance traveled in 12 seconds. Traveled in 12 seconds is equal to distance traveled in 10 seconds plus distance traveled in next 2 seconds. Distance traveled in 10 seconds, how to find? Everything is given over there. That is half base, half into sum of parallel sides. This part is 10 and this part is 4. Because 2 and 6, their difference, this part is 4 and this one 10, and time gap is what? 6 minus 2, that is 4, plus d2. d2 means this area will not make this one negative. Area below time axis will be negative, but will not take negative. They ask to find distance. For displacement you will subtract, but here you add. So this is again half base into altitude. This is 2. And in 12 displacement is minus 2.5. Clear? Okay. My God, this distance I have taken wrong. It is not 4. It is given 5. So half 10 plus 4 into 5. Half into then 2. 2 is the length. I mean this portion, and this is 2.5. No negative sign. So this is going to be 14 by 2, 7 into 5 plus 2.5. 37.5 meter is the distance traveled. Displacement would be what then? It will be 35 minus 2.5. That is 32.5. Clear? Now this one. This is a very important topic for both school-based examination and entrance examination. Concept is very important. Object is thrown vertically upward with a velocity 19.6 meter per second. It strikes the ground after some time. Draw xt, vt and at graph. Let me do it. Object is thrown vertically upward with a velocity of 19.6 meter per second. And it strikes the ground after some time. After what time? If we go back there, motion under gravity, I remind you another thing that is called maximum height. You remember it? U square by 2g. Time of flight. Time of flight means time taken to go up and then to come down. T equal to 2u by g. And another very important fact. Suppose you are standing here, your hand is there. Okay? You have thrown a projectile with velocity u from here, or you have thrown it from here, someone thrown it from here. Here velocity is say 10 meter per second. At this point when it is going down, it will have the same velocity. Okay? This velocity will be same. We can discuss with the help of equation of motion only. Another thing I would like to say, when the particle is allowed to fall freely, it will travel. This I have discussed in previous sessions, that the distances traveled in successive seconds. This is h1 in 1 second. This is h2. And next one h3. Successive seconds it is traveling. This one first, then this portion, then this portion. Okay, I am taking this portion as h2 only, this portion as h2 only, distance travel in second, this one distance travel in third second, that is h3. Then h1, h2, 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 h3, as you have seen before, this is going to be 1, h2, 3, h2, 5, like this. This you should keep in your mind, because nowadays you have to answer both descriptive and MCQ there. So let us solve this one. Object is thrown vertically upward with a velocity 19.6 meter per second, strikes the ground after some time. Draw xt, vt and at graph. See, when you are drawing xt graph, displacement versus time, what maximum distance it can travel, that you write first. H equal to what? U square by 2g. U square is 19.6 whole square by 2 into 9.8. It is given by 19.6 only. So the height above the ground, it goes 19.6. This is time, and you are doing displacement time graph x. And what is the time of ascent? It is just u by g. 19.6 by 9.8, 2 seconds. So this is say 1 second, this is 2 seconds. Sorry, extremely sorry. That 2 seconds, it will go up. This is 1, this is 2, 3 and 4. Total time of flight is 2t. 2t equal to 4 actually. This is just time to ascend, time to descend. Now, when you are going to plot the graph, this x or h 19.6, you split as it is coming multiple of 19.6, you take it as 9.8, this one 9.8. I mean, total is 19.6. We have taken this point as say 9.8 meter, 19.6 meter on the graph paper. Then up to this time, it will be like this. Up to what time? 2 seconds. In next 2 seconds, it will be like this. Okay, clear? So this is 1 second, 2 seconds, 3, 4. This is the graph, xt graph for the entire journey. Now we have to do it for velocity time graph. So xt graph is done. Let us do velocity time graph now. Vt graph. How to draw the Vt graph? This Vt graph what kind of graph you expect there? This is per projectile thrown upward, but its acceleration acting downward, g downward. Velocity time graph is called acceleration, deceleration, whatever you see. Since it is directed downward, it will be sloping downward. It will be sloping downward from some maximum velocity. You have thrown it with the velocity 19.6. This will decrease. Okay, so this will be the graph. This graph has slope negative. So this one is Vt graph. Please don't forget this. Particle thrown upward, its Vt graph is this. Maybe velocity 0. Why maybe it will be 0? This we can do. At what time velocity will be 0? Velocity will be 0 when it reaches the maximum height. Maximum height it reaches in 2 seconds. Clear? They have not told about rebounds on the ground, so we'll not go for that. Okay? VT graph is like this. Now, when it is going down, then velocity gradually increase, and at the lowest point it will be 19.6 only. It returns back to the same point after 2 seconds only, after 2 more seconds, and with the same velocity. So on the graph, these two going to coincide. I mean, started from this point here it will stop at the same horizontal level. This is VT graph. When it is thrown upward, for upward motion velocity time graph is like this. For downward motion velocity time graph is like this. A to C, then C to B. Clear? Hope you have understood. And then let us draw the acceleration time graph. Number 3. How to draw AT graph? Let me draw. But what to draw there? Nothing to draw. Because acceleration is permanently, it has constant value, minus 9.8 meter per second square. We have taken upward direction positive, so this downward quantity has to be negative. If you say that no, I have fixed up in upward direction, okay, fine, you do it. But I will be taking, in all our problems we have considered this, so I will be taking, it's like this, time increases, but this remains the same, that is minus 9.8 meter per second square. There are some standard problems from kinematics, motion in 1 dimension. 2 dimension we have not started yet. See what kind of sums are there. Some problems are calculus based also there, that I will be discussing. So this is not calculus or graph based, I think. Car starts moving rectilinearly, first with acceleration this, then uniformly, and finally decelerating at the rate of omega. This omega, what it is given there, 5 meter per second square, comes to a stop. Total time of motion equals with 25 seconds. Average velocity during that time when it was moving uniformly. Total time is 25 seconds. Average velocity during that time means for entire journey given 72 km per hour, how long does the car move uniformly? This is the question there. Read the question, I will be solving it. Car moving rectilinearly, first with acceleration. Actually, this one, it is better we plot the graph. I was telling that without graph we will do, can be done definitely, but let me do without using graph. I am not going to use graphs here. No, I am going to use graphs. So this will be velocity time graph. This, don't be confused. W means here they have given acceleration. So this is going to be velocity time graph. First they told first acceleration. At first it has acceleration. Then it goes uniformly. Then it is returning. Clear? So start from here. accelerating O to A, uniform velocity, then returning. Graph is correct. This velocity they have not given, but they have given acceleration. Here acceleration 5 meter per second square. For this also acceleration 5 meter per second square. If I assume that the maximum velocity it has gained is v0, that will be right decision. This time be t1, this time be t2. T2 means the time through which it is in uniform motion. And this time is again t1. Clear? So what about total time here? They have given total time. So what is given there? Let me write. Given t2 plus t1 plus t1, 2t1 is equal to 25. This is given there. Now average velocity is given. Average velocity it is given 72 kmph. Five by 18 meter per second. So it is 20 meter per second. Alright. T2 plus 2t1 25. Average velocity 20. And total time they say 25. How does it help? Total time and average velocity if you know, displacement, then you can write in this graph. Displacement V average into time. Time is 25. This is 500 meter. So displacement is 500 meter. Number 2. Do you have any way to get displacement from graph? Of course. Here displacement from graph is given by displacement is equal to half base into altitude. Altitude is what? V0. V0 is the altitude. And this thing is equal to 500. Okay. This is our number 3. 2t1 plus t2 you know. So what does this imply? V0 equal to 2 into 500, that divided by 2t1 plus t2, the total time is 25. This is 40 meter per second. Clear? So V0 equal to 40 meter per second. This is the maximum velocity it has gained that we got. But we have to get the time t2. T2 how can I get? Very easy to get. Here acceleration they have given omega or w, whatever say. So for this portion we use the slope concept. For this portion from O to A, V0 by T1 equal to W. So this W we are getting, or T1 we are getting. T1 is V0 by W. V0 how much? That is 40. And W how much? W we got, W it is given, that is 5. W means that acceleration. Acceleration is slope. So this you put there, that is V40 by 5. This is equal to 8 seconds. Substitute there. T1 plus T2 is what? 2t1 plus t2 is 25. t1 we got 16 plus t2 equal to 25. So t2 equal to 9. So 9 seconds it was in uniform motion. So average velocity of the point during the time of motion will be V average, that is delta S by delta T. Displacement is quite obvious. What is that? Displacement is 2 meter. And what time? This time is 20 seconds. Graph is intersecting finally there at this point. At this point. So delta is going to be 2 meter and time is 20 seconds. So I am taking this one 200 centimeter by 20 seconds. 10 centimeter per second. Clear? Average velocity of the point during the time of motion done. Now, what is the maximum velocity? What is going to be the maximum velocity here? What is the concept of maximum velocity here? That we have to understand first. For maximum velocity, the slope of the curve will be maximum. So V is maximum when ds by dt is maximum. Okay? So what you have to do there? The concept I told you initially, you have to go on drawing tangents. ds by dt is slope of tangent. Slope of tangent means tan theta. So if you draw it here, you can mentally draw. Don't draw actually. If you draw it here, you can draw anywhere. But here it is going to intersect, not possible. Tangent drawing very difficult this way, I mean this side. You can draw it this side. Now, after this point, if you draw it here, draw. Point is going to be like this. Am I correct? That point is going to be like this. Now, I have to say in which case the angle, ds by dt equal to tan theta is maximum on the graph. You have to go on seeing at which point it is maximum. That one, isn't it? Check at which point it is maximum, giving you time. Maximum slope, then maximum value of velocity. Maximum velocity. So at which point? Graphically you think. I think it is more steeper at this point. Maximum steepness occur at this point. The graph will be more steeper at this point. If I make it bigger for you, then you will understand better. Think at this point it is more steeper than any other point. Okay? So at this point, slope of tangent you have to find. From this point, draw a perpendicular. Then you can find slope of tangent. Displacement is what? There. Okay, let me redraw. So velocity will be maximum, where slope maximum, I detected this point. Tan theta will be maximum here. See the approximate value. This thing is 100 centimeter and this part approximately 4 seconds. Okay. So here that V max equal to ds by dt max This is equal to 100 by 4. This is 25 centimeter per second. Clear? This is the answer, 25 centimeter per second. There is another part of this question. Let us answer that also. The other part of the question is the time moment at which the instantaneous velocity, this question is very, very important, sir, is equal to mean velocity average over the first 20 seconds. This is not 10, this will be 20 seconds. Average velocity and instantaneous velocity, they will coincide where? Particle starts from here. For average velocity, that average velocity will be direction of average displacement. So find the point on the curve where the line segment joining origin, as it starts from here, origin to the point will be coinciding with the tangent drawn at that point. So let me see approximately where it happens. Here it will not be tangent. If you meet it here, no. Here it will not be tangent, going to be at this point. At this point on the graph, this point P on the graph, the direction of OP equals with the direction of tangent at that point. So what is the point P? You have to answer in terms of time. This is 10 plus 2 plus 2 plus 2 after 16 seconds. So the second part, if you are answering for a descriptive question, you have to tell that we find the time instant where direction of tangent coincides with the direction of what? Direction of V average. So that point approximately correctly we found at the point P. So required time interval going to be, required time is equal to 10 plus 2 into 3. Why 2 into 3? Because time is shown here. 10 divisions and 20 seconds. So for each division time is 2 seconds. That's why I have taken 16 seconds. Let us go for next one. Just check the sum. A point traverses half the distance with a velocity v0. Remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for other half of the time. Find the mean velocity of the point averaged over the whole time of motion. Let me explain. You'll be able to do it, but let me do it first. So it is given particle traveling, point traversed, particle traversed. Okay. Half the distance with velocity v0. This is half the distance s. This is another half of the. So total distance AB I am taking 2s. Total distance AB I am taking 2s over there. So s it has traveled with velocity v0. So time interval for that will be what? What is the time interval here? Wait. Here, if total time is here for this part, till midpoint done for this distance, v1 velocity for half time. So suppose m to n it goes with velocity v1, n to v with velocity v2. v1 for half the time. So what is the time here? t1 s by v1. What about this time? T2, it will be S by V2. I hope you have understood. This is clear. And total distance is 2S. Your problem is to find mean velocity of the point averaged over the whole time of motion. What is the mean velocity for the whole time of motion? Whole time of motion is what? In our consideration, time of motion is equal to T plus T1 plus T2. And displacement is what? S plus S, that is 2S. So therefore, average velocity V average equal to net displacement by net time. Clear? Just substitute those values, then you'll be getting. it. But there is a problem here, which I did not say, because these have taken S by V1. This is not true. It is S1 by V1. S1 stands for what? Because they have given half the distance. Total distance is half. So if this portion is S1 and this portion is S2, then time will be S1 by V1, S2 by V2. So displacement S, when you are taking, it's fine, but the second S equals with S1 plus S2. Clear? Now do accordingly. Is it possible to find the distance S1, those time? You think and answer. You assume this time T and this one T, then S is equal to S1 plus S2. So S1 is what? V1 into T, and this is V2 into T. So S is equal to V1 plus V2 into T. Now T means the total time. T means here total time, but this T, again this T and this T will be different. They are not same T. This T and this T not same. So here you keep it T dashed, T dashed, T dashed, T dashed. Okay. So now if you write, it is going to be 2S by T. T stands for what? S by V0. T1 plus T2 is what? 2T dashed, isn't it? T1 plus T2 is 2T dashed. And from here, T dashed I am getting 2S by V1 plus V2. Done. Everything is coming in terms of V0, V1, V2, whatever given over there. This is get cancelled. Take LCM. 2 V0, V1 plus V2. And this is going to be V1 plus V2 plus 2 V0. It's a tricky sum. This sum I have taken from, probably from Resnick-Halliday. I observe that this is a good problem where thinking must be in such a manner that you understand the whole process of average velocity, then mean or average velocity, whatever you say, and half the time, half the distance, this kind of concept. This is just an example. You can get example bit changed from here. Now let us do next one. Not this one, this one. Three points are located at vertices of equilateral triangle whose sides equal A. they all start moving simultaneously. This I am describing the way you can answer a descriptive question, no? With velocity v constant in modulus, with the first point heading continually for the second, second for third, and third for the first. How soon will the points converge? If this is a descriptive question, then you have to answer accordingly. If you don't give enough reason, then it will be cancelled. So these are 3 points of an equilateral triangle of side length A. What is happening there? All are moving. This one leaves this point, this one leaves this point, leaves this point. But after some time, it cannot continue the straight line path because it is heading towards B. B is here. So its path is changed. Similarly, C's position here. B's path is changed. C is approaching A. A is somewhere like this. So its path is changed. Okay. Again, it happens the same manner. If you join them, if you join these 3 points, then it is going to be a reduced equilateral triangle because they have the same velocity. So your answer will be in such a manner that the external the examiner understand what you are going to say. So you will be stating this manner: at any instant, the 3 particles are situated at the vertices of a reduced equilateral triangle. Alright. So from here it again goes this way, this one again goes this way, this one again goes this way. Again reduced equilateral triangle. Then again it starts the same manner. So finally where they are going to converge? They converge at the centroid of the triangle. Finally, they meet at the center of the triangle. So you need to find just displacement. For A, displacement from A to O you need to find, or C to O, the meeting point, or B to O. Since this is an equilateral triangle, you have an advantage that OA, OB, OC all are equal. It is 2/3 of height. Height is how much? √3 by 2A. So this is going to be A by √3. So required time will be what? Required time will be displacement by velocity. What is the displacement here? A by √3, and component of velocity in this direction. Partly vector concept is required. U this way, U or V, whatever given. So component of velocity in this direction will be V cos theta. V cos, this theta is 30 degree. Put the value, it is coming to be 2A by 3V. Today I am telling you how to answer a descriptive question, no? From kinematics, not MCQ. So you need to mention all the steps, all the explanation. Physics is such a subject which has its own language. It is not mathematics. So only mathematical calculation we never do, you explain it and then proceed. Now I am going to show you one relative motion problem. Relative motion, in the main session I have discussed with some problem on relative motion, but this kind of problem I haven't discussed before, which is important to revise when you revise the concept of motion in one dimension. Okay, this relative motion problem also I have taken from one dimensional motion only, but this time motion is under gravity. So you read the problem, then I will explain what to do there. Just read it. Elevator car whose floor to ceiling distance equal to 2.7 meter start ascending. This is the elevator. It start ascending with what acceleration? 1.2 meter per second square. Floor to ceiling distance is given, that is 2.7 meter. Then the problem is that bolt is there. Bolt is there at the ceiling. It has become loose due to some reason. So lift is moving upward, it is experiencing maybe pseudo force, whatever, downward direction, or it has become loose due to some maintenance problem. So it starts falling. Question is the bolt's free fall time, displacement and distance covered by the bolt during the free fall in the reference frame fixed to the elevator shaft. Elevator shaft means that cord. Okay, this portion is called elevator shaft. It is due to this shaft, it is getting force upward, it is moving. Whatever, that we will discuss later. So you have to discuss the motion with respect to something which is fixed in it. This is the problem. So to solve the problem here, we will be finding velocity of the bolt and the lift after 2 seconds. 2 seconds they said, no? So velocity of bolt, velocity of lift after 2 seconds, it is going to be what? Acceleration is given, starts from rest, so 2.4 meter per second. Then what is happening there? Lift is accelerating upward. This one is velocity and it is controlled by gravity. It cannot move with lift now, its motion will be controlled by gravity. But due to inertia, the loose bolt will have upward motion first and then it starts falling. In the meantime, lift's position is changed. Lift will be reaching the bolt's position after some time. I am just drawing a rough sketch. Bolt will reach there. So that the bolt touches the ground. So bolt, how does it touch the ground of the lift? It goes upward and then it comes back this manner because its motion is free fall. Bolt's motion is under gravity. Clear? Bolt's motion is under gravity. Motion of lift is under this acceleration. So lift will travel some distance, bolt also will travel some distance. Let the bolt touches the ground after, let the bolt touches the floor after time t. Then what is happening there? If it touches the ground, touches the floor of the lift after time t, then distance traveled by lift will be what? At, 1.2 t, because it has no initial velocity. Sorry, not 1. it also has got some velocity, no? At that moment, what is the velocity? The velocity of lift and velocity of bolt same, that is 2.4t plus half into 1.2 into t square. Okay, its motion remain accelerated. H bolt, how do you find? This is going to be half what? H bolt is minus ut, upward direction, no? Initial velocity in upward. So minus 2.4t plus half into gt square, because g downward direction. You can take 9.8 or 10, unless otherwise stated. It is better you take 9.8 always. Clear? Sum of these two distances, HL plus HB, has to be equal to the height of the lift. That is equal to 2.7 meters. Put it there. So this implies, if you add these two get cancelled. Half into 1.2 plus 9.8, sorry, t square is 2.7. So t square is 5.4 by 11. So this is the time, root 5.4 by 11. I am taking the help of calculator at this moment. Let's see what is its value. 5.4 by 11. I'll find it. 5.4 divided by 11. Square root of this thing. Approximately coming 0.7 seconds. Okay. So time I got 0.7 seconds. But question is not time of flight. Question is, oh, total bolts free fall time. Yes, that is 0.7. You got the first part. Now displacement and distance covered by the bolt. Displacement of the bolt we found here. HB equal to this thing, 0.7 you substitute. There it is done. But distance is what? It has gone some height this manner and then it has come back. That displacement is not taken into consideration. So displacement of the bolt, this I am writing SB equal to that U square by 2G. Going up, then coming down, that plus this HB. HB is calculated here because bolt is free fall. It is going up, then coming down. Then it touches the ground. So when it goes up, then coming down to the point from where it is detached, then falling down. So you have to add. So it is U square by G plus HB. HB stands for displacement. Displacement also they have asked, and this is the distance double. HB is the displacement. You put 0.7 over there, and this will be half into 9.8.7 square. I hope you understand the concept. U square by G will be 2.4 square by 9.8, and this HB what you get that you add here. Am I correct? Hope you have understood. So this plot is displacement of the bolt, and this part going to be this part plus HB. This is the distance traveled by the bolt. Clear? You understand?